Hello, geography enthusiasts. I'm NAVJOT, your guide through the world of Earth sciences. As a passionate geographer, I've spent countless hours exploring the wonders of our planet, from the highest peaks to the deepest ocean trenches. My fascination extends beyond the visible landscapes, reaching into the dynamic processes that shape our world beneath the surface. But here's the thing. I believe that the beauty of geography lies not only in understanding these complex theories, but also in making them accessible to everyone. That's why I've made it my mission to break down these intricate concepts into bite-sized, easily digestible pieces. And what better place to start than with the continental drift theory, a theory that has revolutionized our understanding of the Earth's past, present, and future. So buckle up, my fellow Earth science aficionados, as we embark on this exciting journey together. Now, let's dive into the fascinating world of the continental drift theory. The continental drift theory sounds complex, right? But trust me, it's not. Let's dive right in. Picture the Earth, not as a static, immovable object, but as a dynamic planet with its surface constantly shifting and changing. This is the essence of the continental drift theory. At its core, it's the idea that our continents, those vast expanses of land that we call home, are not fixed. Instead, they move. They drift over the Earth's surface, like colossal rafts floating on the planet's molten interior. Now, this doesn't happen overnight. We're talking about a process that unfolds over millions and millions of years. So while we might not feel the ground moving beneath our feet, rest assured, it's happening. This theory, though seemingly simple, has profound implications for our understanding of the Earth. It helps us make sense of everything from the distribution of plants and animals to the occurrence of earthquakes and volcanoes. The continental drift theory wasn't just pulled out of thin air. There's a story behind it. This tale begins with a brilliant mind, Alfred Wegener. In the early 20th century, Wegener, a German meteorologist and geophysicist, made a bold claim. He proposed that the Earth's continents were once a single landmass that had drifted apart over millions of years. Imagine the shockwaves this sent through the scientific community. It was a radical idea, breaking away from the then accepted belief that the Earth's landmasses had been fixed in their places since the dawn of time. Wegener faced significant skepticism and even outright dismissal, but he held his ground, confident in his hypothesis. As the years passed, more and more evidence began to align with Wegener's theory. The scientific community slowly but surely started to take notice. Today, we regard Wegener's once controversial proposal as a fundamental tenet of modern geology. Despite the controversy, Wegener's theory has stood the test of time. Every good theory needs solid evidence, and the continental drift theory is no exception. Our first piece of evidence is the fit of the continents. Look at a world map and you'll notice an interesting puzzle-like fit between certain continents. South America and Africa, for example, seem to complement each other perfectly. This is no mere coincidence. The idea is that these continents were once part of a supercontinent called Pangaea, which later broke apart and drifted to their current locations. Next, we turn our attention to the distribution of fossils. Fossils of the same species have been found on continents that are now thousands of miles apart. Take, for instance, the Mesosaurus, a freshwater reptile whose fossils have been discovered in both South America and Africa. Given this creature's limited ability to swim, it's highly unlikely that it crossed the vast Atlantic Ocean. The more plausible explanation is that the two continents were once connected, allowing the Mesosaurus to inhabit areas in both. Additionally, we find matching geological features across continents. Mountain ranges, coal fields, and glacial scratches that align on separate continents again suggest that these landmasses were once joined together. The Appalachian Mountains in North America, for example, have the same age and structure as the Scottish Highlands. These similarities are difficult to explain unless these areas were once part of the same landmass. There's also paleoclimatic evidence, which involves studying past climates to understand the Earth's history. Ice Age evidence found in places like Africa, India, and Australia suggests these regions were once situated near the poles, despite their current tropical and temperate climates. So we have the jigsaw-like fit of continents, the distribution of identical fossils, matching geological features, and paleoclimatic evidence. All these pieces of evidence point towards the same conclusion. Our continents were once part of a larger supercontinent and have drifted apart over millions of years. The evidence is compelling, isn't it? But what does it all mean? To fully grasp the continental drift theory, we need to understand plate tectonics. Now, imagine the Earth as a giant spherical jigsaw puzzle. The pieces of this puzzle are what we call tectonic plates. These slabs of rock, which comprise the Earth's outermost layer, are constantly moving, albeit at a pace slower than the growth of your fingernails. The tectonic plates float on the semi-fluid layer of the Earth's mantle, known as the asthenosphere, driven by the heat currents rising and falling within the Earth's interior. These plates move around, collide, pull apart, and even slide past each other. It's this movement that is primarily responsible for the drift of continents. Alfred Wegener, the pioneer of the continental drift theory, suggested that all continents were once a single landmass, which he named Pangaea. Over millions of years, the tectonic plate movements have fragmented Pangaea into the continents we know today. So the continents are like giant puzzle pieces, constantly moving on the surface of the Earth. The movement of continents isn't just an interesting fact, it has real-world implications. Let's delve deeper into the impact of continental drift, which extends far beyond the shifting of land masses. It has a profound influence on our planet's climate, biodiversity, and even the formation of natural resources. Firstly, consider climate. As continents shift, they redirect ocean currents and winds, which in turn impact global weather patterns. For instance, imagine a continent moving away from the equator and towards the poles. Over millions of years, this shift can cause the climate of that landmass to transition from tropical to polar. This has happened many times in our Earth's history, with continents journeying from the equator to the icy ends of the planet and vice versa. Next, let's talk about biodiversity. When continents drift apart, species get isolated from each other. This isolation can lead to the evolution of new species, a process known as speciation. Think of Australia, a land teeming with unique creatures like kangaroos and koalas. These animals evolved in isolation as Australia drifted away from the supercontinent Gondwana about 80 million years ago. Finally, we come to the formation of natural resources. The movement of tectonic plates can lead to the creation of mineral deposits and fossil fuels. For example, the formation of coal, a vital fossil fuel, is directly linked to continental drift. Ancient, lush forests got buried under sediment as land masses shifted. Over millions of years, heat and pressure transformed these buried plant materials into coal. In essence, the drifting of continents is a silent force that has been shaping our world for billions of years. From the climate we experience, the diverse life we share the planet with, to the resources we depend on, the effects of continental drift are omnipresent. Continental drift shapes the world we live in ways we might not even realize. We've covered a lot of ground. Let's summarize what we've learned. Our journey started with the continental drift theory, a fascinating concept that reshaped our understanding of the Earth's surface. It's the theory that continents, those massive land masses we call home, are not fixed in place, but instead drift across the Earth's surface. Quite a moving thought, isn't it? We delved into the origins of this theory, tracing back to the early 20th century and the pioneering work of Alfred Wegener. He proposed this revolutionary concept, challenging the then widely accepted belief that continents were immovable. Wegener, however, wasn't deterred by the skepticism. He saw a jigsaw puzzle where others saw a static map. Then, we explored the compelling evidence that supports this theory. The fitting coastlines, the matching fossils found across oceans, the similar rock formations, and the distribution of ancient climates. Each piece of evidence, like a puzzle piece, adds to the complete picture of our drifting continents. Of course, we couldn't discuss continental drift theory without touching on plate tectonics. This is the mechanism that powers the movement of continents. The Earth's lithosphere, the rigid outer layer, is divided into several large and small pieces, called tectonic plates. These plates float on the semi-fluid asthenosphere below, moving in response to the heat currents in the Earth's mantle. It's like a slow-moving conveyor belt on a geological timescale. And let's not forget the impacts of continental drift. It's responsible for the creation of mountain ranges, the opening and closing of oceans, and even the evolution and distribution of species. It's a force that has and continues to shape our world in profound ways. The continental drift theory is a testament to the dynamic and ever-changing nature of our planet. Keep exploring, and as always, stay curious.